Arithmetic Progression, also known as AP. Now, in this particular video, we are going to talk about the basics and the term formula related with arithmetic progression. Now, look at the following number series. In the first series, 2, 4, 6, 8, you can easily predict what the fifth number in the sequence is. That is 10. The reason why you were able to predict the missing number was that each number is obtained from the previous number by the addition of a constant value, which is 2 in this case. T represents term. T1 means the first term, T2 means the second term, and so on. A progression is called an arithmetic progression if the difference between successive terms is constant or common. This is known as the common difference. It's always the second term minus the first term. It can also be the third term minus the second term, and so on. Any term higher up in the series minus the term before it. Now let's look at the second series. 100, 95, 90, 85. Naturally, the next one is 80. What is being added? Well, you can say 5 is being subtracted, but in AP we will use the terminology of addition. We will use the mathematical operation of addition. The addition could be of a positive value, negative value, integer, decimal, fraction. In this case, negative 5 is being added. Look at the third series, 1.0, 1.2, 1.4, and so on. A constant value of 0.2 is added. Similarly, in the last progression, 0, 1/4, 2/4, 3/4, next one is 4/4, which is technically 1. So a constant value of 1/4 is being added. Now let's define some terms. A stands for the first term. D stands for common difference, which is already discussed on the previous page. D is second minus the first term, third minus second, and so on. And then we have N. N is the number of terms. You can also say that N denotes the position of the term in the series. For example, if I say N is equals to 5, that means that there are 5 terms in that series. Not necessarily, unless and until if I say the number of terms in the series are 5. So N is 5. Maybe a series has 100 terms and I'm dealing with a particular part of the series. I'm dealing with maybe 20 terms. So for that case, N would be 20. L is the last term. Tn stands for any particular term. For example, if N is 5, T5 would mean the fifth term. In that series, the position of the term is 5. Sn, sum of n terms. For example, a series consists of 10 terms. If I say S10, that means starting from the very first term till the 10th term, this formula, which will come in the second video, this formula will give us the sum of all the terms. Now, the term formula, that is A plus n minus 1 bracket multiplied by D. How many variables do you see over here? How many terms do you see? You see Tn, you see A, you see n, and you see D. There are 4 terms, and mathematically you know that if 3 of them are given, you can always find the 4th one. Look at the series of odd numbers starting with 3. And I know that the next number after 9 is going to be 11. What if I were to use this formula? A is 3, common difference is 2, n is 5. I'm looking for the fifth term. So therefore, the fifth term in the series comes out to be 11. Similarly, 3, 5, 7, all the way till 99. The series is going starting from 3 all the way till 99. I want to know how many terms are there in the series. This series is finishing off at 99. Therefore, my last term is 99. And Tn, since I don't know the value of n, so for me the Tn, that particular nth term, is 99. First term is 3, common difference is 2, Tn is 99. Again, using the formula, the term formula, I can find the value of n. This time n is unknown, so with a little bit of basic math, 99 minus 3 is n minus 1 into 2. One small word is that you don't have to multiply out the 2. You can simply divide first and then make n the subject. So n comes out to be 49. Now, let's look at this number pattern. 1, 2, 3, all the way till 100. These are consecutive integers. If I ask you how many integers are there, that's a basic kind of a question. Of course, you know the answer is 100. But I'm just using the formula for the sake of using the formula. A is 1, D is 1, Tn is 100. Again, using the term formula, I get n to be 100. But now the next question is slightly different. How many multiples of 5 are between 5 and 100? Now, is 5 a multiple of 5? Of course it is. Is 100 a multiple of 5? Of course it is. So the examiner does not necessarily have to use the word inclusive. 5 by default is inclusive. 100 by default is inclusive. So therefore, the first term is 5. The common difference is 5. Last term is Tn. Again, using the term formula as we have used before in the previous two examples, I can find the value of n. Therefore, n comes out to be 20. That means there are 20 multiples of 5 between 5 and 100. We can also count it on our fingers if we don't trust the formula. But what if the numbers get bigger? Naturally, you have to use the formula. Similarly, how many multiples of 3 are between 1 and 100? Now this time, 1 is not a multiple of 3. 100 is not a multiple of 3. Therefore, what's the first multiple of 3 after 1? That is 3. What is the last multiple of 3 just before 100? That is 99. So A is 3, common difference is 3, Tn is 99. Again, using the same formula, this time n comes out to be 99 minus 3 divided by 3 is n minus 1. Therefore, n is 33. Now, look at these question. That's one particular question with a number of different parts. Find the number of terms in each of these APs. For example, in part E, 97, 85, 73, ... all the way till 13. First term, 97. Common difference is negative because the terms are decreasing, and just stick to the concept that common difference is always second term minus the first term. Again, applying the term formula, we get the value of n. Now, if you look at these questions, there are some with decimals in it, there are some with fractions in it, and there are some with a lot of plus sign. If there are a lot of plus sign, that simply behaves as a comma, 97, 85, 73. But if there is a minus sign, of course the minus has a significance, 9, minus 11, minus 31, and so on, as in part G. One more example, you can see it for yourself. This time it's in decimals. Decimals are part of life. And still you get the same answer. You get this answer along the same pattern, that is finding the value of n. These are the answers for those questions. You can try them while you are done after watching this video. Now, one more thing. This term formula, how do you think it came into being? Because this basic concept is required. The term A started to start a series. The term A is determined to start a series. A is the first term. A value of D is added. So the next term is A plus D. D is again added. So the next term is A plus D, which is A plus 2D. Another value is added. So A plus 2D plus D, that is A plus 3D. T1, T2, T3, T4. If you look closely, in T1 there is no D because A is the only one that's starting it. In second term, that's A plus D. third term a plus 2d, fourth term a plus 3d. That means whatever is the subscript of t, whatever is the value of n, the number of d is always 1 less than that. A is always fixed, a is always 1. That's why we have the formula Tn is a plus n minus 1 into d. And for those people who are not very satisfied with this methodology, with this logical reasoning, what they can do is that they can plug in different values of n in that formula, and of course they will get the same answer. Now let's look at the word problem. Question number 8. In an arithmetic series, the third term is 4, eighth term is 49. Find the first term and the common difference and the sum of the first 10 terms. I'm not dealing with the sum of the first 10 terms right now. The main thing is solving simultaneous equation in two unknowns to find the first term and the common difference. T3 is 4, T8 is 49. What is T3 in terms of A and D? That's A plus 2D. What is T8 in terms of A and D? That is A plus 7D. Now, solving a simple simultaneous equation. When I use the word simple, I mean a linear simultaneous equation. There are two ways. One is solving simultaneous equation using elimination. And that's the one illustrated on this first example, first method. What I did is that I took the second equation and multiplied throughout by a negative sign. I changed all the signs and simply added it up. And this is basic maths. Everyone knows it. It's just a brief refresher. You first find the value of D, then you find the value of A. If you were to use the second method, which is the method of substitution, you can make A the subject from one of the equation and plug in the other one, or you can make A the subject from both and then equate them. A is 4 minus 2D, A is 49 minus 7D, and the rest is obvious. 4 minus 2D is 49 minus 7D. Therefore, D comes out to be 9 and A comes out to be negative 14. Now, this first video that sums up what basically is an arithmetic progression, what are the different term formulas to be used. There is only one term formula, and what kind of word problems can you come across.